750 centenarians and their families, and I should say that we've learned so much about this project, but from a genetic perspective, we're going to validate it. American Federation of Aging Research, is going to launch, and we have the money from a single donor, an effort to recruit 10,000 centenarians so we can really find all the longevity genes and confirm them. But basically, we had three hypotheses with centenarians. One is that they're doing everything that we should do with the environment, right? Ashley, what you would recommend to people to do? They exercise, they ate well, they ate the right things, they had lifestyle of the blue zone kind of lifestyle. And maybe that's why they get to 100, because when they were in the community, when they were growing up, when they were middle age, that wasn't the recommendation. Maybe they just happened to do it right. The second hypothesis is, we know that there's a lot of genetic risk, genetic SNPs, okay, we called it, or variants that are associated with diseases, with Alzheimer and cardiovascular disease and cancer. Maybe those guys just don't have any of that. They have like the perfect genome, okay? And if that's not true, well, maybe they have genes that slows their aging, okay? So let me go one by one. As far as interaction with the environment, 60% of the men, 30% of the women were heavy smokers. I have a woman, 110, and more, almost 95 years she was smoking, okay? So if you smoke for 95 years, you can live long life. In fact, when I asked her, I met her when she was 100 years old, and I asked her, nobody told you, your physicians didn't tell you to stop smoking? And she said, all four physicians that told me to stop smoking, they died. 50% of them were overweight or obese. Some are obese as centenarians as well. Doing even moderate kind of work, of exercise, walking or biking or housework, less than 50% of the people. Vegetarians, 2% of the people. And we could actually compare our cohort to Enhance 1, that's the National Health Survey. Enhance 1 was the cohort that they were part of. and when we compare them, they're kind of the same or sometimes worse. So we are pretty sure that we can say that there's nothing in that in the environment. I should say we have another papers, because it's not only centenarians. We're looking at the children of centenarians who are healthy, and we had this paper where we showed that children of centenarians had half of the cardiovascular disease of our control. Those are people who don't have family history of longevity. But we accumulated lots of nutritional surveys, not only nutritional, we have BMIs and exercise and socioeconomy status, and a lot on macronutrient and nutrients, and they were all the same between those two groups. They were all the same. The only difference was children of centenarians, okay? And they had 50% less of cardiovascular disease. Okay, the second hypothesis, they have the perfect genome. So our first 44 centenarians, which were sequenced for whole genome sequencing, okay? So we had only centenarians, not control, not anyone, only centenarians. But there's a website that's called CleanVar that at that time accumulated 15,000 genotypes that if you have them, you're most probably to get a disease. And we said, let's look, if they have 0, then they have the perfect genome. Not only they didn't have 0, they had on average 5 variants that should have made them sick. And they didn't. They had 44 centenarians, there's 250 variants that should have made them sick. And by the way, those variants are impressive. For example, ApoE4, homozygosity for ApoE4 is a major risk for Alzheimer. You're demented by 60, 70, you're dead by when you're 80, according to the textbook. And we have two centenarians who are 100 years old and not demented. Okay, so if they don't do exercise and if they don't have perfect genome, something else slows their aging. Okay, and so what is it that slows their aging? And we make lots of progress there. And I'll just say for this podcast that the most impressive genotypes or the genomic features of those centenarians, that 60% of them have functional mutations in the growth hormone pathway. Okay, in other words, their growth hormones are not active. And this is really interesting because it really tells you that when you start aging and there's a breakdown, you have to shift the energy from growth, which you need for evolution, reproduction, to, okay, let's deal with a breakdown now. And in fact, we validated those findings. There's an hypothesis in aging that's called antagonistic pleiotraphy. Something that's good for you when you're young is bad for you when you're old. Okay, cholesterol. We need cholesterol for the brain, for the ovaries, for the testes. But if we have a lot of cholesterol metabolism when we're old, we're going to clog our coronaries, right? So it's antagonistic pleiotraphy. IGF is the same. We took data from the UK Biobank. Anyhow, it's a big data where they had measures of one of the growth hormone, the important growth hormone, IGF-1. And we basically showed that when you're young, it protects you against variety of disease and mortality. And when you're old, it's the opposite picture. It accelerates you. When you have IGF, protective when you're young, kills you when you're old. So there's a major genotype for that as just one example, because there's a lot in this pathway that we discover in centenarians. It's just not working well. And we certainly think that it's related to that. By the way, even when you're a centenarian, okay, when you're a centenarian and we measure this IGF-1, this growth hormone, the women with the lowest growth hormone when they're old, when they're a centenarian, live twice as long as the women with the highest growth hormone level. So, and they have better cognitive function and, lots of other things. So this is an example of something that we realize is very important. By the way, dwarf animals live longer. Okay, the small dogs live longer and the ponies live longer. And when you do in the lab where you mutate or you get dwarf animals, they always live longer. Even there's a dwarf larron, a special kind of dwarfism because they don't have a receptor for the growth hormone. And we're not sure that they live longer, but they have less cancer and less diabetes and other diseases. So